Okay, welcome to the lab, first of all, and now let's talk about why the low spinning heel kick is such an effective move, and we're going to be talking about this from a pure physics point of view. Okay? Let's just get right into it. Impulse. What exactly is impulse? Impulse, I, equals to the change in momentum. Got that? Impulse is the change in momentum. Impulse is also force times time. Impulse is also force times time, and that equals to the change in momentum, and we can write the change in momentum like this. mv2 minus mv1, okay? And this m is constant, so we can also write it like this. Ft, which equals to impulse, equals to m times v2 minus v1, okay? Right off the bat, v1 out of the picture, it's 0. Why? Because we're assuming that our opponent is initially standing still. Our opponent's not moving. Our opponent's legs are standing still. Before we do the move, our opponent, we're assuming that he is standing still, which is going to be the case, most likely, right? So v1 equals to 0. So we can write this equation out like this. Ft equals to mv2 or mvf, final velocity. Okay? The value that we're interested in this equation right here, the value that we're really interested in is this value right here, is the v2 value. So let's rearrange this equation so that we isolate this v2 value. So v2 equals to ft over m. What does all of this have to do with the spinning heel kick? What does that have to do with anything? Well, it has to do everything with the spinning heel kick, because this is what makes the spinning heel kick such an effective move, okay? Let's break this down. Why is the move so effective? Number one, this time value. This time value we already discussed before. When we do the spinning heel kick, it's not just like this. It's more of a sweep. So the contact time is much longer than if it was a punch or a kick. This is a sweep, so the contact time between my heel and my opponent's leg will be pretty high. So time will be high. Okay? That's a terrible arrow. Time will be high. Next, force. Okay, now let's take it back a little bit. Let's look at this force over here. This force, and we're talking about force. This is the force that's applied by my heel when I do the spin. This F value is the force that's applied by my heel onto my opponent's leg. This force value, will it be high or will it be low? Let's think about it like this. We know that force equals to mass times acceleration. Okay? We know that force equals to mass times acceleration. When we think about the spinning heel kick, the spinning heel kicks, what's special about the spinning heel kick is that during the spinning part of it, during that phase, the acceleration of my heel just goes up all the way. Until the moment that I hit my opponent's leg, my acceleration has boomed. During the whole spin, during the time of the spin, my acceleration has went all the way up. And when this acceleration value is high, we know that the force value, since force equals to mass times acceleration, we know that the force value will also be high. Okay? So, that being said, the force value is high and the T value is high. What this means is that this V value will also be very, very high. And when this V value, when this V2 value is high, that means that our opponent's leg will go flying after we do the spinning heel kick, and thus they're gonna fall on the ground. When their leg goes flying, they will fall on the ground. The only really factor that we haven't really talked about is this mass. Okay, what about this mass? This mass comes into the picture this mass only really affects this V2 value this mass will make this V2 value pretty low if the mass is very, very high. So what this basically means is that if your opponent is like a is a heavy guy, you know what I mean? If he's a heavy guy, then this V2 value might not be so high, but nonetheless, we still have the force and we still have the time, and both of these values will definitely be high. So this move, the spinning heel kick, will likely work unless your opponent is like massive, which, well, we're just gonna assume that he's not, okay? And there you go. That's why this move is so effective. The physics is just, it's on point. The force, boom. The time, boom. And that means that the V2 is also all the way up, which means that your opponent should go flying if you apply this move correctly.